Alright, so we're on problem 11C of the final exam practice, and in this problem we want to find the Maclaurin series, the first three terms, and the radius of convergence for the power series representation of this function, the indefinite integral of e to the power x squared. So in a problem like this, we want to find the power series representation for an integral of a function. So if we can find the power series representation for the function itself first, then we can write the power series representation for the integral. So we first write a power series for e to the power x squared. And so what we notice is that this is e with x squared as its power. And so we can use the power series representation for e to the power x. And this is just whatever the input is to the power n divided by n factorial. And we go from n equals 0 to infinity. Okay, and so we can rewrite this as a power series starting at n equals 0 going to infinity, x to the power 2n divided by n factorial. So just distributing the n inside the parentheses there in the numerator. Okay, and so here's our power series representation for e to the power x squared. And also we know that the radius of convergence for this is positive infinity because this is coming from the power series, the Maclaurin series rather, for the exponential function, which has radius of convergence positive infinity. Okay, so now we just want to take the integral of this. So we're going to integrate e to the x squared with respect to x. This is our function, c of x. All right, so we write the power series for the integrand. So we have n equals 0 to infinity, x to the power 2n divided by n factorial. Okay, and we're integrating with respect to x. So we have constants here that we can pull out. So first of all, to integrate this, we're just going to switch the order of integration and summation. So we get sum, n equals 0 to infinity. We get a 1 over n factorial that comes out because this is just a constant. And we want to integrate 2 to the power n with respect to x to the power 2n, rather, x to the power 2n with respect to x. Alright, so we just need to find the antiderivative of x to the power 2n. But of course we just use the power rule here. So we're going to add 1 to the power and then divide by that power. So for each term, we'll get one of these. So it'll be x to the power 2n plus 1 divided by 2n plus 1. And then we have a plus c because we just took the indefinite integral. So we always get a constant from that. All right, and so here is our series for integral of e to the x squared. You can rewrite it as just constant plus x to the power 2n plus 1 over 2n plus 1 times n factorial, and going from 0 to infinity. And we know that the radius is still equal to positive infinity. And so the reason that the radius of convergence is still positive infinity is because when we integrate a power series with a particular radius of convergence, that radius of convergence does not change. So the last thing that we want to do is just find the first three terms of this power series. So I guess I'll do that over here. Okay, so for n equals 0, we'll write out that term. So for n equals 0, the power in the numerator is x to the power 1. And then I have a 1 down here, and then a 0 factorial, so it's just 1 in the denominator. So the first term is just going to be x plus, and then with a n equals 1, so we have x cubed in the numerator. We have a 3 and a 2 factorial, so that's just 6. And then the third term is going to be from n equals 2. So we'll have 2 times 2 plus 1 is 4 plus 1 is 5. So x to the power 5 in the numerator. And we still have our constant over here, forget about that. And then this will be 5 times 3 factorial, so that's 6. That gives us 30 in the denominator. And then we have several other terms, but this is just the first 3 terms of that Maclaurin series. Okay, so that finishes problem 11C for us.